Okay, so now it's recording. Okay, so what we are going to look right now is at matplotlib, right? So this is a plotting module. So it's the same tutorial as yesterday. It's right at the end of the tutorial here. So let me open it again. Yeah. So this is it over here. Yeah. So before we start, do you have any comments or questions that remain from yesterday that you want to ask right now, or? Yeah. Okay. We'll have exercises about this also, and then we can really see what we learned, right? So let's just now we had finished yesterday with functions over arrays. Okay. And now, how do you plot using matplotlib, right? So plotting looks a lot like if you have learned plotting in R, right? It's kind of similar. Usually, you have to have arrays that contain or either lists or arrays that contains the points, and you just pass these arrays, and this will be read as x and y in the plot, and then it can plot dots, can plot lines, and so on and so on. Okay. To import matplotlib, you do it like this. It's a little bit different from NumPy because the matplotlib is a library with a lot of tools inside, but then the plotting routines exactly are inside a submodule inside matplotlib called pyplot. Okay, so you have to import the submodule and not matplotlib itself. Okay, so you import pyplot from matplotlib. This is not a function, this is a submodule, okay? And inside this submodule, there will be a lot of plotting functions, okay? Okay, and I will skip this because, well, if you are in Jupyter in your own computer, usually when you plot stuff in pure Python or in a notebook in your computer, the plots pop up, okay? They pop up. They just like in R, right? They pop up. They don't appear in the middle of the document. Okay. So, but you can make it appear inside the document with this command here. Okay. But in the lab, it always appears in the middle of the document. So we don't have to worry about this right now. Okay. So the first example here, this is a very simple plot. I have here an array from 0 to 10. In steps of 1/2, okay? So this is 0, half, 1, 1.5, up to 9.5, okay? And now you see that there's already an issue here, right? Can anyone tell me what is this problem here? Why does this happen? Why did this happen? Yeah, I didn't define NumPy, right? So I didn't import NP before, right? Why is that? Because I started the notebook from the ending, right? So I had imported it all the way up there. I think right in the first few, yeah, right here, you see. And then I didn't import it again down there, right? So let me just, instead of running everything again, I just opt this. Here again, okay? So I think this makes sense. Yeah. So importing NumPy here. Okay, let me try again. So what does this do, right? I define x, and then I say, well, x is an array. Sign of x is a different array that is, as we saw yesterday, is an array that each element of it is the sign of x, and then I plot y against x, right? And then you get this plot over here, okay? Pretty simple, right? Yeah? Yeah? Pretty simple. So the default plot is filled with lines, has this way here, okay? You can add a lot of stuff here, okay? So for instance, we can give titles to the plot, to the x-axis, to the y-axis, like this. So you can have a grid here with this function. So you have x label, y label, the title of the plot here, the grid. So you have a series of functions to add elements to the plot, okay? so there's nothing very difficult about it, right? And so it's always a good idea to have this block like this, right? So you always label your axes, give titles. Grids sometimes is useful, sometimes is less useful, but anyway. So here it is, right? And now, what happens if we want to change the type of the line, right? So this is simple. You come here, and the third argument here. So plot is a function that takes several different arguments. You see that there are a lot of optional arguments for this function. Okay, what are these optional arguments? There are more details about colors, type of points or lines, width of the lines. There are many details that you can change in the plot. Okay, of course we won't go over all of them. Okay, but the basic ones at least. So if you want to have dots instead of lines, the third argument here you put is a dot. Okay, so when you run this here, you see the same plot as before, but now it's this one in blue here, okay, with dots, okay. Now down here I have a plot of the cosine with dot. These two dots here is a dotted line, so this is the cosine here in orange, right? And with two lines here, two hyphens here, you have this dashed line, okay? This dashed line. And you can explicitly tell the color by using color equals to the name of the color, okay? Red, blue, green. There are a lot of names of colors, but I think you can also include a hash with the X odds of the color. Do you know what I'm talking about? Yeah? The odds of the color, yeah? You can also do that. Yeah. And then, so you have here three plots here. The first one with points, the second one dotted line, and then dashed line. And here I add labels, the title, and the grid. Okay, so this is what appears over here. Okay, any questions so far? This is easy, right? Yeah, yeah. Okay, okay. So now we can also limit the interval that is shown. So if I plot 1 over x, okay, with x starting from -1 up to 1, okay, what will happen? So this is -1, minus 0.99, 0.98, 0.97, until 1, okay? So what happens with 1 over x? What is the range of values in the y-axis? Any idea? What happens with the function 1 over x with x from -1 to 1? What is the shape of this plot, of this graph? So it goes as it approaches 0. What happens to this? It goes to minus infinity, right? Of course, numerically, the closest value to 0, at 0 it will give you infinity, which it is not plotted. Okay, it doesn't try to plot infinity. It usually just gives you a warning. But then the closest point you have to this is, I think, 0.01 below or above 0, right? So you have minus 0.01 and plus 0.1. So this will actually be a range from minus 100 to 100, right? Of course, if you plot it with with a smaller step here, it will go even down and even up, right? So if you don't limit this scale, let me omit this first. If you don't limit this, you have a plot that is not very nice to. Well, this is 1 over x. You see, that's funny. It actually tried to plot 1 over. Because 0 is not exactly 0, right? So there's a 10 to the 15 here. You see? Because it actually let me plot this. Let me print this thing here, right? So yeah, it's just to make sure that we know what is going on here. Okay, so let me print 1 over x here. So you see what is going on here, right? So this is well, there are a lot of numbers actually. So it goes down, 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 minus 8, minus 9, minus 10, and so on, negative, 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 until this, minus 100, and then this should be the infinity number, right? But since 0 here is not exactly 0 because you're summing in 0.1, 0.01, 0.01, this is not exactly 0, so it doesn't give you infinity, it gives you 10 to 15, okay? Which is a very large number and takes all of the other numbers out of this area, you see? So you don't see anything, right? So that's bad, right? So what do you do then? You limit the range from a range that you can see more stuff, right? So you, for instance, go from minus 20 to 20, right? And now you, let me stop this printing here. So now, what you see is something that is more or less what we expected, right? So this I plotted with dots here, right? So yeah, so it doesn't show a continuous line, yeah? Okay, so this is more or less what we expected, right? So now the y range, even for the plot, goes up here and down here. It shows only the range that we want, right? So this is the function y lim here, right? So this is, it takes a single value that is a range from minus 20 to 20, okay? Of course, you can do this with x lim also, right? So we can also limit the x range with x lim, right? So this is pretty much the same thing. And then we can also change the scale, right? In the sense of changing from a linear scale to a log scale, right? So everyone knows what is a log scale. Yeah? So, so here I'm plotting the exponential function, okay? And then when you plot a exponential function in a log scale, it becomes what? It becomes a line, right? Yeah. So let me plot this without changing the scale. So this is the exponential function, and this again will be a, yeah, something like this. Okay, it goes up to 10 to the 6 here. You see, from very close to 0 to 10 to the 6. If I use this function y scale and pass the argument to log, so y scale and x scale for the x-axis receive either linear or log, okay? And linear is linear scale, normal scale, the default one, and log is the log scale. And I do this, I have a line here, okay? And you see that the y scale now is in powers of 10, okay? It's in powers of 10. Nice? Okay. What else? Legends, okay? Legends. So if you have several functions or several plots in the same, several curves in the same figure, you want to label which one of them, okay? So for instance here I'm plotting both sine and cosine, right? And I want you to tell what are the names, right? So to do that, you have this function called legend, where you pass a list of strings, okay? Each string will be the name of one of the curves. So the first one that I plot, this appears in the order that I would plot, okay? The first one was sine, so oh, this in Portuguese too, right? So this is sine of x, and this is cosine of x, okay? So here it is. Okay, and then there's this this log argument here that tells you where in the figure the legend is going to go, in the top right, in the top left, in the middle, in the bottom, and so on, right? And there's this best here that tries to guess, okay? Tries to guess. So if I run this, I have the sine and the cosine, and you see here that it shows you nicely here which color is which, okay? Yeah. This the best here. You see that he found a corner that is free, right? It's kind of free here, down here. Okay, it would force it to go to the upper right, for instance, if I want to do that over here, right? So yeah. Okay. Okay. And this is it for now, right? So there are a lot of other things to learn about Matplotlib in terms of other kinds of plots. Especially 3D plots are nice and so on, right? But I think it's more useful to learn this as you need it, right? So actually, besides these basic plots, Matplotlib is much easier to use by looking at examples and seeing what code does that kind of plot, right? So I really recommend, if you have a certain plot in mind, to go to the, where is it now? I think it's in the beginning of the section. Yeah, to the Matplotlib gallery, okay? And you see here a lot of examples, okay? So the link is in the notebook, and you see you have bar plots, you have all kinds of funny plots. Pretty much any kind of plot that you want in your life should probably be here somewhere, you see? So there are many of them, you see? So with several panels, with panels of different sizes, with, I don't know, these are what, violin plots, you know, any kind of plot that you may want in your life, pizza plots and so on, right? So you can just click at any example here, and besides the plot itself, it will give you code that does that plot, right? So then you look at this code and you look at how you can adapt this code to your purpose, okay? So this is usually very easy to adapt, right? So you don't have to learn by heart all kinds of plots there are, right? You just have to know where the gallery is, and now you want this kind of plot, you go there, you see how to do that, okay? Yeah? Yeah, for now we will mostly use only this simple 2D plots, right? But then later we may want to use more complicated ones, okay? So, okay, this is it. Do you have questions? Yeah? No? This was pretty easy, right? Yeah? So let's now go back to the exercise, okay? So there are the exercises from yesterday, okay? So these 3 ones here, and now I think we can at least try to, I think the 6th one, there won't be time for us today, but maybe we can advance. The 5th one is, I think, is pretty simple. The 4th is already a bit more complicated than the previous, but maybe we can try to do today. And then there are the second set of the exercises down here. That is a set of exercises about NumPy arrays especially, right? At the end there's something about plotting, but I think the most interesting one is about creating arrays, matrices, and slicing them, okay? So we have now it is 2:25, about 3 we stop and then talk about the exercises from yesterday, okay? Before moving on, okay? Good. So let's try to at least go to the 4th exercise from yesterday. If you want to go further, of course, if you have time, okay? Let's do that. Yeah? Okay, let's do that. Okay, exercise time now. Yeah.
We should start by yesterday?
Yesterday, yeah, start by yesterday, then we stop, talk about the exercises from yesterday, and then we start on these exercises later, okay? Okay, good. So I'm not sure what is the best way to go about this. If you want to send me some, oh, it's not open, right? So you can, yeah, let me see if it's open here. Yeah. So you can, do you prefer to send me or won't anybody ever send their own code for me to show up here? This is something too scary. Just for us to be able to comment on the solutions, right? So, yeah, okay, so the first one, this one with the Pythagorean triangles, right? So this was, I think, the easiest one, right? But then the idea is that you just check if when you take square of A with square of B, if this is equal or not to the square of C, right? So if I have, for instance, this one, we we will have that this is true, and if I take another one, this will be false, and I just have to check. And then you have a function that just does that. I think this didn't generate a lot of doubts, right? Yeah? Yes or no? This is the moment to ask final questions about after you have done this, right? So, well, this is taking a bit too long. Okay, so this returns true if I have this other situation here where this is not triangle rectangle. You have false here, right? So this condition here is false, okay? So what do you have to do? You just have to include this condition here inside your function, okay? You put this here, okay? And since I want to return true if this is true and false if this is false, I can either do an if, but I can also do this very smart thing that I return this directly, right? So that if this is true, it returns true. If this is false, it will return false. Okay, so I don't need the if else, but I would also, so this works. Okay, you see that it passes the test, but you can also do if this thing here is true, right? If this is true, then return true, and if the editor again is 2, 4. Yeah. Okay. So this is 4. Yeah. So and then if this is false, that is else, you have return false, and this also works. Okay. So this is simple, right? This looks simple at least, right? But then this is a little bit dangerous, right? This is a little bit dangerous because of one thing here, right? So suppose that because here we are working with integers, right? So I kind of trick it. It is a little bit tricky that I only included integers, right? But remember that if I have floating points instead of integers, then you have rounding errors, and then this comparison here may not work very well. Okay, so if I had, instead of running with 3, 4, 5, what if I run, what if I check here with points here, so saying explicitly that these are floating points instead of integers, right? Something like this. Well, this is true, right? Let's try something, maybe 1, 1, and the square root of 2, right? This is another triangle. Let me import math here. This is usually better done in the beginning, right? So just to show that even very simple stuff can be tricky, right? So yeah, it's square root of 2, right? So this is 1 square root of 2. And this is false. Even false, it should be true, right? But then you have rounding errors, and this is squared plus this is squared plus this is squared is not exactly equal, because the square root of 2 squared, when you do this with floating points, is not exactly 2, right? So if you do this with integers, you're safe. But if you do this with floating points, then this comparison is not safe. Okay? Yeah. Okay, this is the Pythagoras theorem, right?
Não,
Yeah.
mas tipo, quando você faz isso, você está assumindo que o usuário está botando uma ordem crescente, né? Porque, por exemplo, se ele botar 3, 5, 4, aí então é Pythagoras, você está falando
Okay. Bom, well, this is more or less because this is, I told you already in the test here that C will be the largest one. Okay, so because I told you. Of course, if you want to be sure, right, and you can say, okay, you can do this something like if I don't need this. If C is smaller than A or C is smaller than B, print wrong order. And just quit, right? Return nothing actually, because you don't even know if it is true or false. Okay. Of course, if you want to be really smart about it and just look for the largest one and call that one C, and you see, you can also receive in any order if you just go and look for the largest. Okay. Yeah. But the exercise was simpler, right? You just asked it for, well, you know C is the largest one, all right? This is kind of given already, okay? Yeah? Okay, so this is it, right? So I am really complicating a very simple exercise, okay, sorry. Now the second one, the Fibonacci sequence. Anyone has questions about this? Well, everyone managed to do it? Yes? Yeah. The point here is that if I do 1 plus 1 squared plus 1 squared, even with the point here says that this is not an integer, it's a floating point, okay? That's the difference, it's the type of variable. But then this, of course, gives you exactly 2, okay? That's no problem. But the problem is that the square root of 2 squared, that this should be exactly 2, right? But it is not, you see? It's not exactly 2 because there's a rounding error, okay? And then when you compare this thing here with this thing here, it's not the same, okay? So when you do operations with floating points, comparing floating points with for equality, it's very dangerous, okay? So be careful, okay? So usually what you do is that you take the module of the difference and ask if it is very, very small, okay? Yeah? Okay, so next, Fibonacci sequence, okay? So here what you have is, okay, if I have these 2 initial values here, okay? How do I calculate the next? Well, I have to, always when you calculate the next one, you have to take the last 2 terms, right? What are the last 2 terms? Well, the last 2 terms are Fibo. The last term of the last element of a list is Fibo minus 1. And the other one is Fibo minus 2, okay? The next to last, okay? So this gives you the next value, right? What do I have to do to this? I have to add it to the end of the list, right? And then, and how do I do this? How do I add to the end of the list? With append, right? So I append this, and now I have, let me print this list here. So now I have another element, and then if I do this again, right? If I do exactly this stuff again, what do I have? I have another element to the list, and so on, right? So I just have to write a function that does this until I have enough elements, okay? So how many times do I have to do this? If I want n, I have to do this. I start with 2, right? So well, actually I have to check if n is 0 or 1, right? But then so let's do it like this. So if n equals 0, I can return just the 0, else or elif n is 1. There are several different ways of doing this, right? So return 0, 1, and else if you have more than 2, then you start with Fibo 0, 1, right? And then you do how many steps? You do n minus 2 steps, right? If you want 10 elements, you have to add 8 elements, right? So you have 8 steps of doing this thing here, right? So I do for n in range, not n, right? Oh, I in range. N is the number of elements over here, right? So if I want 10, I have to do this 8 times, right? So I do n minus 2, and then I append new elements here to the end. And in the end of this stuff here, I return this list here. Does that make sense? Yeah. So this is my way of doing this, right? So this is one way. There are several different ways. Okay, you can do this a little bit differently, but the general idea is in this direction, right? Yeah.
It's more a request. After this class, can you upload your way of doing things so we can study that too afterwards?
Yeah, I just want to caution you that trying to study my answer is not perhaps a good idea because it reflects, I don't know, my taste, my way of working on things, and usually it's better to spend your time trying to do more exercises so that you train how to put your way of thinking into code.
Yeah,
You
but
see?
for example, I didn't understand exactly what you wanted.
Ah, okay. Okay, so I have more time to, yeah, sure. Yeah, sure, yeah. But keep this in mind, right? My way is not the only way or the single right way. There are several different ways of doing stuff, okay? So, if anyone did it in some way very, very different and want to comment, okay? Please do, right? Please do. Yeah, you can tell me, well, I did this in this other way, and then we can discuss that, okay? Yeah? But this is very uncomfortable usually, right? So I'm doing this in my way just because I think it's uncomfortable for people to just show for everyone, right? What is No? Okay. So moving on or not? Yeah? Yeah? So, well, hopefully, where are the tests here? Did I erase the tests or there were no tests in this?
There were no tests.
Oh, sorry. Yeah, sorry. So let's try Fibo 10 here and see. Oh, set Fibo, yeah. Just sure. Oops, and there's an error. Oh, okay, so this is, oh, what happened here? Fibo equals, yeah. Yeah, here it is, right? So 10 elements here, okay. Okay, good. Now, the smallest power of x. So let's start with this, right? So what would you do to, if I have, let me print this, right? So I have here 10 to minus 100 and 10 to minus 1000, right? And as we discussed, this will be, the first one will be a floating point that is not 0, and the last one will be 0, right? And of course, if you try something in the middle, okay, in the middle, you will have something that might or might not be 0, right? So minus 300 is still non-zero, minus 340 is already 0. So sometimes something around minus 300 to 340 is the number I want, right? So what do I do, right? So I have to I have to look for the first number that will not be 0, or the first one that will be 0, right? So I have to decrease in the negative integers until I find the first one that is 0, okay? So is this clear for everyone? But then there's a catch, right? Because I don't know how large this number will be, right? I don't know. It would be minus 1,000, minus 10,000, minus 1 million, minus whatever, right? So yeah, I really don't know. So I cannot use a for loop, right? So this looks like a for loop. I go from minus 1 up to minus what? Minus infinity, right? But there's no way to represent an infinite list, right? So you have to, instead of this, keep checking and keep reducing the number, the exponent, until you reach a number that is 0, right? So pretty much like we did here, right? So one way to do this is well, you have 300, and then 301, and then 302, and so on, right? Until you do this. Of course, it's very boring to do by hand, okay? But you go one by one here until you find one that is 0, right? So I think it's the 224, right? So this is 0, and the previous one is not 0, okay? So this is 323 is the 323 is the one that we are looking for, right? So how do you do this, right? So what do? You say, okay, while x to this number n, right? I haven't defined n yet. Okay, so let's start. What is the initial number that I can use here? It's something small, right? So 0, 1, minus 1, okay? It cannot be larger than that, right? I start with 0, but could be 1, minus 1, something like that. And while this is different from 0 or larger than 0, right? What do? You keep decreasing n, right? So you can do this here, right? n equals to n minus 1, and I think this is the same thing as minus equal 1, okay? So this is synonymous, okay? So yeah, I'll leave it like this, and that's it, okay? So I test if, so it starts with 0, and then I say, if this is different from 0, that it always is, all right? Then reduce the value of n to minus 1. Check again. X to minus 1 is 0. No. Decrease n. X to minus 2 is 0. No. Decrease n again, and so on and so on. When will this break? When x to n is 0. Okay? And when it is 0, I know that I reached the first one that is 0. Okay? I don't want the first one that is 0. I want the previous one, the last one that is not 0, right? So what do I have to return? I have to return the n before that, the when before I subtracted 1. I have to return n plus 1. Yeah? Does that make sense? So if I try here for, let me just test here, right? So non-zero power of 10, right? That we already know the answer. So this gives you minus 323. Yes. Some questions? One thing here also is that I think I thought I had written here, right? But this will only go to 0 if x is larger than 1, right? If I include here x equal to 1/2, what is going to happen to 1/2 when I go to negative powers? It goes up, not down. So it doesn't ever go to 0, right? And then what do you have here? Infinite loop, yeah? Okay, so maybe you assert here in the beginning x is greater than 1, right? Or this assert that I'm using the test, it means if this is not true, then this gives you an error, okay? Or if you don't want to give you an error, you say if x greater than 1, print x should be greater than 1. Yeah, and you just return here without doing anything, right? Without going into the loop, okay? You have to either raise an error or stop, but you cannot allow it to go into the loop, of course, otherwise you will have an infinite loop, okay? Oh, yeah. It's smaller, yeah. Exactly, thank you, yeah? It's smaller or equal, because 1 also doesn't work, right? 1 to anything is always 1. Right? It doesn't go to 0 either. Okay? Yeah. Sorry? Mesmo sendo float. Yeah, so let's try 1 to, I don't know, minus here, right? So, yeah, with a float here, okay? Because 1, yeah. Because 1 is one of the floating points that are represented exactly. One of the few ones, right? Remember that powers of 2 are represented exactly in the computer. So 1 works, yeah? 1 is represented exactly, yeah. Okay, good. So, well, the tests hopefully work, yeah? Did someone try something too different from this stuff here, or? Of course, there's a question here that is this the most efficient way to do this? Of course not, right? Because I'm going on steps of 1, right? So to reach minus 300, I had to go over one by one, right? Of course, I would go in steps of 10 or 100, and if, you know, I would keep going faster, and then coming back, and this would be a little bit more complicated, but also more efficient, okay? But then we are not so worried here about efficiency, okay? There are other ways that are smarter, but we are just trying to get the hang of things, not trying to be too smart or very efficient and so on, right? And this will be especially true for the next one, right? So I think some people haven't done, who already finished the fourth one? How many? Can you raise your hands? Who finished the fourth exercise? I see 1, 2, 3, 4, anyone else? Okay, so the fourth one is still not there, right? So, oh, it's 3:30 already, so we don't have time for, yeah, so, yeah, I wanted to have time to start the other one. So I won't go into this now, right? So maybe I wanted to go over the second exercise, but we don't have time today, right? So maybe we start this a bit tomorrow, and then we continue on Monday also, right? The second exercise. So maybe the end of the class tomorrow, we can use to work on the second exercise. Okay? Okay? Okay. And then on Monday we go back to discuss both. Okay? Yeah. Okay then, people. So that's it for today. See you tomorrow. Okay? So let me